As you will move on to the more advanced questions of sequence and series, you will be requiring some prerequisites. Generally, I'm against memorizing a lot of formulae because in any case, JEE will never ask you questions that directly requires formulae other than the most basic ones. But in this case, you absolutely have to remember these, the sum of first n squares and first n cubes, if you are to do the more tougher questions that JEE asks and which it will ask. Now, before moving on to it, first let us understand why this is required and why I am telling you to memorize these formulae. Also, it's not only about the memorization of the formula, it is also about how you derive it, because the same processes will absolutely help you in solving other questions as well, in which you might feel that these formulae are not required. Now, understand how this chapter is progressing. In the very earliest levels, you are taught arithmetic progression, geometric progression, harmonic progression, arithmetico-geometric progression, and so on. So there you have to find the sum. The focus is on finding the sum Sn directly. But sometimes what happens as you move on to more advanced questions, the first shifts to finding the general term, which is TR. So what you do is that in those questions you focus on finding the general term, and then you calculate the sum using directly using some properties of the summation operator. This just looks tough, but when you solve those questions, you will realize what I'm talking about. Because these sequences are a little advanced, you get the rth term in certain algebraic forms. For example, the rth term can be of a series can be 5 plus r square. Let's say you have a series of this kind and you have to find the sum. So directly you cannot apply any formula of arithmetic progression because it's not a AP, it's not a GP, it's not an HP. I hope it is not any of that. So you have to focus first on the rth term and find and then find Sn. For instance, the rth term of a series can be something like this. So when you find S, that is, you have to do summation of TR. And when TR has certain exponents like n square, n cube, n, this is what mostly J will ask you, mostly. So you can directly apply the summation formulae or the summation of n square, n cube, and find S directly from TR. So understanding what I'm trying to say, instead of directly adding, you first have to find TR and then apply the summation formula. So for that, you will be required what is the sum of first n cube, first n squares, first n numbers, and so on. I hope it was clear. If not, just move ahead. So the first will be the sum of first n integers. This is easy because this is an AP. So S1, the required sum is 1 plus 2 plus 3 plus 4. AP with first term A, common difference D, and number of terms is n. Straightforward sum of formula, sum of terms n by 2, 2A plus n minus 1 into D. You simplify it, nothing very complicated here. Let's move on to sum of squares. The required sum here is 1 square plus 2 square plus 3 square, so on up to n square. Now, since remember this, if the exponent here is 2, you will increase the exponent and focus on an equation whose exponent is 1 more than the required one here. So because it is 2 here, you will require 3 here. So if you focus on n cube minus n minus 1 cube, you will get n cube minus n minus 1 cube, 3n square minus 3n plus 1. So focus on this now. Okay, we will just write it down. The difference we will write it down. So n cube minus n plus 1 cube is 3n square minus 3n plus 1. Now, instead of n, put here n minus 1. Okay, everywhere in this formula. So n minus 1 will become n minus 2. 3n square, n square again, we are putting n minus 1. Similarly, here also we are putting n minus 1. So you will get n minus 1 cube minus n minus 2 cube. These are cubes. Okay. Similarly, do for n minus 2 and move on until you get 1 cube minus 0 cube. And now simply add them. So if you'll add them, what we'll see, first focus on the LHS. These terms will get cancelled out. There is no term, in any case it is 0, but there is no term to cancel this out. If there would have been some term here, this would have cancelled out, but there is no term here, right? So this will remain as it is and n cube will remain as it is. So bring it here, n cube minus 0 cube is, now focus on RHS now. So here you have 3 n square, n minus 1 square, n minus 2 square, n minus 3 square, so on till 1 square. So basically move in this way. So what you have, 3 comes out common, 1 square plus 2 square plus 3 square, so on till n square. Similarly, here you have three constant common 1, 2, 3, n minus 2, n minus 1, n. So you have 1 plus 2 plus 3 so on till n, and you have 1 n times. So this is the expression. This is what we have to calculate. And these are all basically given. How? This is n cube. This is 3 times s. S is the required sum. The first n natural numbers. Sum is n into n plus 1 by 2. And this n comes here. So finally, this you have an equation. 3s is the required sum. Move all these terms here. 3s is equal to n cube minus n plus 3n into n plus 1 by 2. When you simplify it, you will get s2, which is the sum of first n squares. You will get n into n plus 1 into 2n plus 1 upon 6. So that is the first sum that you were required to calculate. That is the sum of first n squares. Similarly, the first n cubes, as I said, n 1 cube plus 2 cube plus 3 cube plus so on to n cube. Let us call it s3. As I said, here the exponent is 3. So here the equation or the expression will be we will be calculating will have the exponent 3 plus 1, that is 4. So again, focus on n raised to power 4 minus n minus 1 raised to the power 4. This will come out to be this. How? You can simplify whenever you find it difficult on calculating powers of 4, you can always reduce it as n minus 1 square and its whole square. That is n a minus b square, a square plus b square minus 2ab. Okay, and square it. Then again, whenever you have something like a plus minus b plus minus c whole square, it is very easy to open the bracket. First of all, write a square plus b square plus c square as it is. Okay, then suppose you have a plus b, so it will be 2ab. Okay, multiply each term. Suppose it is b minus c, it will be minus 2bc. Similarly, if it is minus b plus c, again it will be minus 2bc. If it is a minus b minus c, it will be plus 2bc. So in this way, you have to change the sign of 2a, 2ab plus 2bc plus 2ca depending on the signs that are here. So here, because this is plus, this is minus. Okay, so 2n square plus 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 4n plus minus minus 2n cube plus minus minus. So in this way, you can easily expand n minus 1 raised to the power 4. So finally, what we required was n minus 4 minus n minus 1 raised to the power 4. So n minus 4 minus, this is what we have to subtract from that. So finally you will get 4n cube minus 6n square plus 4n minus 1. Okay, so big page, but do not jump ahead. Focus on one line at a time. So you get n raised to power 4 minus n minus 1 raised to the power 4. This is what I have copied from the previous page. Similar to how we did in n square, replace n by n minus 1. So you will get n minus 1. Here you will get n minus 2. Here you will get n minus 1, n minus 1, n minus 1, minus 1. Similarly, keep on doing it till you reach n 1 raised to power 4 minus 0 raised to power 4. Okay, exactly how we did it in the last step. We are replacing numbers one by one. Because again, when you will do this, when you add this, these all terms will get cancelled out. This would have gotten cancelled out if there would have been a sum here. In any case, it is 0. N raised to power 4 minus 0 raised to power 4 is 4 times. Again, these are all sum of first n cubes. This is sum of first n squares. This is sum of first n numbers. And this is minus 1 n times minus 1. It reduces to this. N raised to power 4 is 4. Let us call this the required sum as s minus sum of first n squares plus sum of first n natural numbers minus n. So move all these terms here, you get finally when you will simplify, so you can take these terms out common. This is in an n into n plus 1, n into n plus 1, so this will become 2n plus 1 minus 2. So you will find out after simplifying that you will get 4s is equal to n into n plus 1 into n square plus n. You can easily do this. This is not the tough part. Simplifying it, you will get s3 as n into n plus 1 by 2 whole square. So you have finally gotten the formula of first n cubes as well. Now again, I am reminding you why it is necessary to remember these formulas, because you can get TR as a form of an equation in terms of these n square and n cube. That is, TR is basically the rth term of any series you are required to calculate. So when you will be solving more advanced questions, the rth term won't be as simple as you would have expected in terms of an EP or a GP or an AGP. The rth term would be some sort of a polynomial. So for example, The Rh term of a series can be 5 minus n cube plus 2n square. So this is not a normal series, right? We cannot say based on it that is whether it is a AP or a GP or an HP. But we do not even require that. You can directly sum it use and the summation operator breaks easily on plus minus, and you will finally get TR, basically S, the Sn of the term, which is what you are required to calculate in any sequence and series question, right? My other videos where I have taken past year JEE advanced questions and explained them with respect to theory and how theory needs to be applied or how theory needs to be recalled when in exam stress. So I have focused on theory from that angle, where we'll be teaching difficult parts of different chapters of JEE Maths in a way that can be understood by beginners, plus solving previous year questions and analyzing what is the pattern and how to think when you are writing IIT JEE mains as well as advanced. Because theory is something that every coaching classes or every coaching manual or every textbook will tell you, but how to apply or how to recall those theories while applying them in an exam situation is what we will be covering here. Thank you.